All right, what we have here are two linear equations which are intersecting. And our goal here is going to be to find the solution graphically. It's called a system of equations when you have more than one involved. So the solution is going to be any place where these lines cross. So we just want to get those coordinates of that point of intersection. It's apparently 1, 1 as a coordinate pair. That means, though, that x is 1 and y is 1. That's another way to say what the solution is. You could state it as a coordinate pair, as a x, y, or you could just say it as the solution is x equals 1 and y equals 1. Those are two different ways to say it. For letter C here, we're not given the graph, so we have to generate it ourselves. In the past, I showed a table method for graphing lines. The table method went like this. Yeah, in the table method of graphing, you would come up with pairs of x and y that you can plot for your line. Now you might focus on just one line at a time here. So maybe I'll use the x minus 2 rule first to get my pairs. Now when you make this table, you have to think about what kind of line you have. Like what kind of rule are you given in your equation. If the rule had involved x only, then that's a special type of line. If it had been something like, x equals 3, then you have to put 3's here as your x's. If it's not involving just x, though, you can pick the x's. Now, if your line had been something like 4x minus 2 equals 6x plus 8 or something, you could still not pick the x's in that case because your equation involves x only. So this table method comes with that little caveat of you have to know when and how to use it. That's a special case. When you have x only, you have a vertical line. Okay, but we don't have that. I'm just showing what could happen here. We don't have x only. We have both x and y. And when you have that, you can pick any x to study. Okay, so I'll just come up with some simple ones like -2, -1, 0, 1, and 2. Then I'm supposed to plug these x values that I chose into the rule, which is the equation. So you write several copies of this x minus 2, leave in parentheses where the x used to be. And then you just go through and plug in one by one. Plug in your -2 in for x. Then plug in your -1 in for x, and just keep going like that until you have several pairs that you can plot. Let's find out what their answers are, though. So we get -4. As a result, -3, -2, -1, and 0. We're then, in this method, supposed to take the -2 and pair it together with his output of -4, and they would make a coordinate pair which could now be plotted. So -2, -4 is the coordinate pair that I need to plot. That's an important skill to have, to be able to make a table out of inputs and then find in the outputs. So we have -1, -3. 0 goes with -2, 1 goes with -1, and so on. Now you just plot those points. So -2, -4, -1, -3, 0, -2, 1, -1, and 2, 0. Then connect your points. So that is one of your lines. And now you just have to graph the other one. And now we have a different rule. Now the equation is y equals x plus 2. Okay, so I'm going to use those same inputs. Why not? 0, 1, and 2. Get our outputs then. This is 0, 1, 2, 3, and 4. Put them together into coordinate pairs now. Now we'll plot that line as well. And connect the dots. They're parallel lines. We can see that because they have the same slope but different intercepts, right? So what's the solution then? There will actually be no solution to this problem because the lines never cross.